All right. Good afternoon and welcome to the second session of the Electronics Hardware Design Masterclass. I hope you had a good experience in the previous session. Okay, so in this particular session, we are going to talk about some interesting stuff. We'll be talking about the basic electronics concept. Okay, we'll be talking mostly about voltage, current, power, Ohm's law, what we mean by a short circuit, and finally we'll end it at capacitance. Okay, and as usual, as we did for the first session, I would give the presentation. The whole idea of the PowerPoint is to establish the foundation, and then once the foundation is built, we can apply the concepts in the projects that we want to do. Okay. All right. Now, I must say that this is one of the most important sessions, and if it is possible, give it a rapt attention. If you have any questions, write them down, and when it's time to ask, you can ask, and I'll do my best to explain everything to you. Okay. All right. So let's get started. Okay. So in the previous session, we talked about what embedded system is, what electronics is. Then I related embedded systems and nervous systems. Okay, and I talked about how they have some similarities. Okay, yeah. So in this particular session, we are going to look at the fundamental concept of electronics. Okay, why does electronics even work? Okay, so everything that we're going to do right now is the most important things that you need to know as a circuit designer. Once this foundation is laid out clearly, trust me, building up on other stuff become very, very simple. Okay, so please, like I said, pay your maximum attention so that you can enjoy this particular course. Okay. All right. So I'm not going to be very detailed about the concepts, right? Because the details involves a lot of mathematics and it tends to be boring sometimes. I should add sometimes. But then I'm going to try and give you the understanding, right? I want you to get to a point where you build electronics with intuition, okay? You don't, you know what you want to do, that kind of thing, right? And then I'll also try as much as possible to make the physical um, how do I even put it? The physical interpretations of the concepts. Okay, I will make it clear. I'll try my best. Okay, so I'm going to use what I call the lumped approach. I'm going to give you the things that you need to at least proceed with this work, right? If you want to do much in, if you want much in-depth understanding with all the mathematics and stuff, we could look at it another time. But for the sake of this, it's going to be about understanding and then building an intuitive approach towards designing electronic systems. Okay. All right. So let's get started. Let's get started. So in this session, our talk is going to be more of a why does electronic even work? Is that okay? Now, before we go, we do anything, we have to make certain things clear. We have to distinguish between electricity and electrical energy. Is that okay? Now, these are two closely related concepts, and I think I've seen people use them interchangeably as if they are the same thing, but there is a difference between them. Is that okay? Uh, yeah, so let's see if we could make this difference clear. Now, when we talk of electricity, we are talking about the flow of charge. Is that okay? When charge, and later we will see what a charge is. When charge moves from one point to another, okay, that flow is what we call electricity. And then this thing is actually associated with a lot of things that we see in our everyday life. Lightning, okay, when we have some lightning strike, you see some light flashes in the sky. Okay, these things are all associated with the flow of charge, which is electricity. Is that okay? Now, when we talk of electric energy, on the other hand, it is the energy that is associated with the flow. Okay, the energy that is associated with the flow. Now, let's say a flowing river, right? A river that is flowing downstream. If I put a canoe or a boat onto the river, the boat end up being moved. Okay, so it means that the flowing river has some energy, and that energy was able to move the boat. So the energy that is associated with the flow, in the language of electricity, that's what we call electric energy. Is that okay? And the river flowing itself is the electricity. So the flow of the charge is the electricity, and the energy that is associated with this flow of charge is what we call electric energy. Is that okay? So take note. Now, if you previously have an experience with electronics, I must say that this particular session is going to bring up a lot of what I may say controversial things, right? But then it's only controversial because of the previous understandings that we've been told. Is that okay? But then I hope by the end of the session you will still get understanding of all that I want to put across. Okay, so yeah, so that is that. Now, if there is a flow, then that means there is a source. Is that okay? If there is a flow, then definitely there would be a source. Let me see, I'm missing something. Oh, okay, I think I skipped. Okay, so just like every physical quantity in science, we associate units to them. Is that okay? So electrical energy, like every form of energy, is measured in joules. Is that okay? It's measured in joules, and yeah, measured in joules. And if I would put it, in fact, if you ask me to, uh, I don't know what to say, but okay. So electricity is the flow of charge, and electrical energy is associated with the flow. I think this is quite simple, right? Uh, Personally, I think I prefer to define electronics as the control, manipulation of the flow of energy, electric energy, instead of the flow of electrons. Because later on we will get to see that the electrons actually, the flow of electrons itself is secondary, right? There is something that is causing the flow of electrons, and that is the flow of this electric energy. Okay, I think things will be much clearer as we move on. Okay, all right. Now, if there is a flow, then it means it's coming from somewhere. Okay, so there are sources of electrical energy, and I know if I should ask you to mention a few, you would say it's at least batteries, generators, and all those kind of stuff, right? Um, oh, I'm not sharing. Sorry. Nobody drew my attention. Hello, can you guys hear me? All right, so I said that in this particular session, we're going to look at the basic concept of electronics, right? It's basically asking the question that why does electronics work? Is that okay? What makes electronic work? And I'm going to use what I call the lambda approach, meaning that I'm not going to be very vigorous about the topic, right? But I'm going to give you enough to understand the whole thing. Okay, I need you to be able to design electronics with intuition. Okay, the understanding is very important, and then I also try and give you the physical interpretations of those concepts that we'll be talking about. Okay, so it's not just going to be concept. I'll try to relate it physically, what is going on. Is that okay? All right, so I said that there is electricity and electrical energy seems the same. Okay, but then there is a difference. Okay, the electricity itself is the flow of the charge. And very soon we talk about charge. For instance, electrons. When electrons are forced to move in a particular direction, that flow is what we call electricity. Is that okay? Now, the energy that is associated with the flow is what we call electric energy. And I cited an analogy as if you take a river that is moving downstream, right? If I put something into the river, that thing will be moved. Okay, that thing will be moved. Now, the thing moving means that some force is working on it. Is that okay? So the movement of the river is like electricity, the flow, right? And the energy that was used to move, let's say the boat I put on the river, that is the electric energy. So anytime there is the flow of charge, being it protons, being it electrons, there is an associated energy, and that energy is what we call electric energy. Is that okay? So take note of the variation. Now, just like every physical quantity in science, we try to associate a unit. Now, energy is generally measured in joule, and electric energy is actually no different from that. So electric energy is measured in joule, just like all other energies, and that is what causes your electrical devices to work. Okay, so to put things in a summary, electricity is the flow of charge. The electric energy is the energy that is associated with the flow. Simple as that. Okay, all right. Then I got to the point where I said that if something is flowing, then it must come from somewhere, right? So we have the sources of electricity. If I ask you to mention them, you would mention at least a battery. Is that okay? Now, what do we refer to as sources of electricity? Already we've established the fact that all electrical devices require electrical energy to work. In fact, the description is in the name, right? Electrical device, that means it requires electrical energy to work. Okay, so what do we mean by an electric source or sources of electric energy? So this includes all things, all systems, all devices that can convert whatever form of energy into electrical energy. Okay, we are not really particular about the main source or the primary source of the energy, but we are only interested in the fact that it's able to convert that energy into electrical energy. Okay, so to mention a few, we can talk of the battery, and a battery, for instance, is converting chemical energy which is found in chemical substances, okay, the chemical elements that we have around. It converts them into electricity by means of chemical reactions, okay. So you hear of something like the lithium ion batteries, the nickel cadmium. These are chemical compounds or elements. So the way they generate electricity is through chemical reaction. So by the action of chemical reactions, they are able to convert chemical energy into electric energy. Okay, then we could also mention the solar panel, which I know everybody knows about. So solar panels convert light energy into electric energy. Now take note that solar itself is a mixture of energies. Okay, if nothing at all, the sun radiates both heat and light. The panels are not interested in the heat. The panels are interested in the light. And also take note that the light that comes from the sun is made up of different wavelengths. Okay, so now depending on the nature of the panel or the how it was engineered, it will be sensitive to certain spectrums of light energy, not all of them. Is that okay? I know silicon panels are usually responsive to the visible region. Okay, yeah, and somewhat into the infrared. Okay, so it depends. It all depends on the material composition of the panel cells. Is that okay? Yeah, but then basically a solar panel converts the light to electricity. There are things that convert thermal energy into electricity. We have the hydro plants to converting mechanical energy into electricity. Then we have generators too. Okay, so anything that is capable of changing one energy form to electricity is a source of electricity. Okay, all right. Now, uh, somebody may ask, why do we have all these sources, and when do I even choose a particular source for an application, right? So it all depends on what you are doing. Okay, whether you would go with a battery or you go with a generator or you use your mains, it depends on what you are doing. So for instance, if we are talking about portable device applications like your touch light, and you know that you want batteries, right? Because you don't want a situation where you have to plug a very tall wire from your touch to your mains. Okay, so in such applications, you have batteries. Your mobile phones, all these things use batteries because they are portable. Batteries store the energy and make it possible for you to move around with it. Now let's take an outdoor activity, for instance, where let's say you are having a function or an event somewhere you don't have access to the electricity mains. Then you could get something like a generator. Okay, generator to serve as a means of powering the equipment for your program. Now in your homes, in your offices, you have the electricity mains, they're great, right? So if you want to power up some things like your air conditioners, right, you don't need batteries for this. Besides, air conditioners even take very they pull so much energy, batteries won't last that much. So in this case, you plug into the mains. So you see, and whatever source that you would prefer or will be ideal for your application, will be ideal for use, depends on what you want to do with it. Okay, all right. Now, um, in this particular lecture, I'm not going to be focused on the, for instance, the chemistry of batteries and all that, right? So we're just going to abstract away the details of the various sources. We're just going to use a very simplified model of an energy source, okay, so that I can use it to explain something. Now basically, every electrical energy source would have two main terminals. Basically, I mean, uh, the mains in our house sometimes have the earth, but the earth technically is not even supposed to carry power, right? The earth is just supposed to channel or excess and leaking current somewhere into the ground. Okay, so basically every energy source would have two terminals. Now one of the terminal will be positive, will be what we call the positive terminal, and the scientific name given to that is the anode. The other is the negative terminal, which we call the cathode. So in general, it's like the terminal is the access points for the electrical energy. Is that okay? The terminal is the access point. Remember, a whole lot is going on in the battery system, for example, and the only place you can access the energy is through the terminals. Okay, now please listen to this carefully. Whenever energy flows, electrons drifts in the direction of the flow of energy. Now, over the years, we've been concentrating on the movement or the flow of the electrons, okay? But the electrons don't just flow. The flow of the electron is secondary to the fact that energy is flowing. Okay, like I said, this session will be a little bit controversial because of the previous knowledge that we have. And I also need you to understand something. I think probably I'll mention that later. Okay, but put this in your head for me, that there is the flow of energy and there is the flow of the charge. The flow of the charge is not the flow of energy. These are two separate things. Charge flows because energy flows. Okay, the charge flows because the energy is flowing. So take note of this for me. We'll come back to it. Okay. So basically, where we've been mentioning charge. What is this charge and where is it even coming from, right? Charge. Good. Now, materials, as we know, or if I say matter, probably basic school should tell you that there's something called matter, and matter is made up of atoms, right? Now, I'm actually trying so much not to really go into the details of these things, right? But there are certain things I still couldn't control myself from not mentioning them, right? So just bear with me. Okay, now these atoms contains three particles. We call these particles subatomic particles, and we have electrons, protons, and neutrons. So these are the subatomic particles. Okay. Now, if you take protons, they are positively charged, and the electrons are negatively charged. Now, this positive and negative is just a convention to distinguish between the behavior of the two charges, okay? So we assign positive to the proton and negative to the electron. For the neutron, the name even describes it, right? It doesn't have any charge. So take note. Proton positively charged, neutron no charge, electrons negatively charged. Now, if you take the atom, there are two regions. We have a central nucleus, okay, very, very tiny, yet very, very massive. And we have the area around the nucleus, or the region of space around the nucleus, which is occupied by electrons. So these are the basic parts of the atom. Okay, so if you look at this picture carefully, we have positive and neutral charges, that's the protons and neutrons sent in the center, and around it we have the electrons. Now take note that this is just a model. It's a way to give you a mental picture of what is happening there. Is that okay? Yep. So the protons and the neutrons are actually bound within the nucleus. Take this carefully. The protons don't move. Neutrons also don't move. Okay? Even if they move by vibrating in any sort or kind, they are still confined, or they do all that in the nucleus. And the nucleus is very, very tiny, right? So practically, protons do not move and neutrons do not move. So I need you to be thinking about this question, that then what do we really mean by positive charges? Because we said electrons are negatively charged, protons are positive charges, right? So if we are talking about positive charges and we are saying protons don't move, then what would be positive charges? Okay, put this question in your head and let's see if you would be able to answer it as we go on, right? Now, for the electrons, they are found in shells. Now, basically, shells are, should I say, region of space around the nucleus where there is a higher probability of locating an electron. Okay. Now, pictorially, we draw it as a circle. Okay, but it doesn't mean that the electrons are in a circle running about. No, that's not what is happening. Okay, this is just a mental model for us to be able to simplify things and work with it. Okay, so this particular circle here is just showing you that there is a higher possibility of finding an electron in this space. The same way there is a higher possibility of finding an electron in this place. That's what the shells represent. Okay, we call them energy levels, or if you want to be technical, principal quantum states. Okay, but we don't want to be technical. Now, this is where everything comes to solidify, right? When we talk of electronics, we are only interested in electrons. Now, take this from me. Protons and neutrons do not partake in any way in the business of electronics. When we talk of electronics, we are only interested in electrons. In fact, that's why the name suggests electronics, right? If protons were part, we could probably call it subatomics or something like that, right? Yes, so take this from me. Now, protons, like I said, and neutrons do not directly partake in the business of electronics. Now, these fundamentals, if you grab them now, would really help you. Now, even for the electrons, right, we can, per space or location, uh, divide them into two groups. Okay, we can divide them into two groups. So we have those that are closer to the nucleus, and we'll call those ones the core electrons, right? And we have those that are in the outermost shell. We call those ones valence electrons. So anytime I mention core electrons, I'm looking at all electrons that are in shells that are not the outermost shell, right? So we have the outermost shell, which is the valence shell, and the rest, which are the core shells. Okay, so an electron in the core shell or inner shells is called a core electron, and those in the valence are called valence electrons. It's just a description, okay? It's just a description. Now, I'm building up to something. Remember earlier I said that even for for the business of electronics, we are only interested in what? You're only interested in electrons, not protons and neutrons. Yes. Well, it even happens that even for the electrons, we are only interested in valence electrons. Okay, both electronics and chemical reactions depend on valence electrons. That means we are not really interested in what goes on in the core shells. Now, there are applications that involve the core shells, something like X-ray applications, right? For X-ray, an electron in the innermost shell has to be released. But for the business of electronics, always stay on the outermost shell, which is what? The valence shell. Okay? This is very, very important, and I need you to understand it. And the reason we will see soon. Okay, so why are we saying that? I think I'm repeating. Okay, so yes, okay. So the valence electrons are confined to a specific area and bounded to their parent. So, for instance, if you look at this diagram here, you see this is the outermost shell, right? And there are this and that electron. So these three electrons are the valence electrons. This outer shell is the valence shell, and over here we have another inner shell. So that will be the core shell with two core electrons. Okay, so an electron in the valence shell is still attached to the parent. Okay, take it as an adult who is still staying with his parents, right? Maybe your senior sister or senior brother is ready to marry and move out of the house, right? But then he or she is not yet married, so staying with the parent. Okay, just any little thing, she can leave the house and go and stay on her own. Okay, so valence electrons are like that. Once they are in the valence shell, they are attached to the parent. But then the interesting thing is that they can easily break away from their parents. And how do they do that? Okay, so the valence electrons are very interesting because of the fact that they can be easily. Now, the key word is easily. With enough energy, we can actually take any electron away from the atom, right? But then we are looking at one that we don't have to spend much. Is that okay? One that we don't have to spend much. Take it. Let's look at this analogy. Let's say that your father is mad at your senior brother, right? Who, of course, is supposed to be married by now. And your father can just say, "Hey, my friend, you have come of age. Leave my house," right? Yes. And society won't bash him for that because, hey, so far as you are of age, you should be able to take care of yourself, right? But then, assuming your father tells your 10-year-old sister that, hey, leave my house, then society will be on his neck because he's supposed to be responsible for the 10-year-old girl, right? So core shells, it takes so much energy to take away the core shells. But for the valence shell, just a little amount of energy, they will break off, okay? sorry, the valence electrons. Okay, so when the electron absorbs energy, and later we will see how it absorbs energy, it can separate itself from the parent shell. So let's say finally your brother lands a very good paying job, then he comes to your dad, hello dad, right now I have a good paying job, I can take care of myself, thank you, I am moving out. Okay, so something like that. So whenever valence shell absorb energy, then it disconnects itself from the parent atom. Okay, now when it disconnects itself in the physics terms or terminology, we say that it has moved into the conduction band. Take note, was first in the valence shell. Now in the valence shell it was bounded to the parent atom, then it moved, it got energy and broke away from the parent shell, and it landed now in the conduction band. Now the conduction band basically represents the fact that the electron is no more bounded to the parent, so it can move through the entire crystal, but there is a catch here. The catch is that it cannot leave the material. Is that okay? So if it is a piece of copper that we are talking about, when the electron break away from an atom, from the parent atom, it can move to any part of the copper material, right? If it's a wire, if it's a copper block, it can move anywhere, but it cannot move away from the copper. Okay, so anytime an electron breaks away from its parent such that it can move freely within the material, we say that it is inside the conduction band. And the catch is that it cannot escape the material. It can just move within the material but not escape the material. Okay, so take it as a house arrest. So they tell you, hey my friend, you can't leave your house. You can move to any part of your house, but you can't leave your house. Okay, so something like that is happening. And in the valence shell, that would be like, hey, we've tied you to a chair. Okay, so you are tied to a chair. That would be like an electron in a valence shell. And this time around, we release you from the chair, and you are supposed to move through your house, anywhere in your house, but you can't go outside of your house. Okay, in that case, then we say that the electron is inside the conduction band. Very, very important thing to note. Okay, I think I would pause here for questions.